Yeah, I'm sharing my screen. I think my screen is visible. We completed with the last class. We completed with the operators and gate level modeling, and I gave some task also. Hope that task is also completed. Means you need to write the programs related to the gate level modeling. Uh, one second, one second. Today we'll discuss about the data flow modeling. Okay. Today we'll discuss about the data flow modeling. One second. Yeah, data flow modeling. Yeah. So data flow modeling. So where you are using mainly in the RTL, we are. I told you that we are using data flow modeling and behavioral modeling. Today we'll discuss about the data flow modeling and signed and unsigned numbers also we'll discuss. Okay. So first we'll see about the data flow modeling. Data flow modeling. So if you see the data flow modeling, we are using a special keyword called continuous assignment statement. Okay, continuous assignment statement, that is the assign. Okay, continuous assignment statement assign. Okay, we are using this assign, and so this occurs when there is any value changes in the right hand side. Okay, so if there any change in the value in the right hand side, then the so that assign value will occur. Okay, assign values, whatever the assign values are there, we are using for the net data types. Okay, when you are using this assign keyword, okay, assign values, so we are using only for the to the net data type. Okay, so whatever the input and outputs, that should be net data type. That means mainly we are using the code wide data type only, and this will execute parallelly. Okay, this will execute in parallel form, sequential form or parallel form. Okay, and this is continuously active. Okay, continuously active, continuously active. Okay, suppose a syntax. What is the syntax for data flow modeling? Is syntax. If you see, assign, assign, uh, uh, so assign and assignment statement, assignment statement, assign and assignment statement. So this is the syntax for data flow modeling. Okay, so here if you see, so example, let us take wire xyz, wire xyz, and so you can use mm, wire xyz aside. Okay, you need to indicate the wire abc also. So wire abc, you are declaring with a wire xyz and wire abc. I am using assign x equal to, I am using b or c. Okay, and assign z equal to b x or c. This is bitwise XOR operation. Okay, and similarly, suppose I'm declaring like wire. Okay, remember that when you are using continuous assignment statement, that is data flow modeling, both input and output you need to declare with y data type only. Okay, that is net data type. Okay, that you need to remember. So x comma y, x comma y comma z. I'm using reg a comma b comma c. Okay, a comma b comma c, and suppose if I am using assign x equal to a and c, x equal to a and c. Okay, there is no error, no error. So that means whatever the reg variables are there, that can come on the RHS side. Okay, but if you give, suppose assign a equal to suppose a or b, Okay, A equal to A or B. So this you will get error. So why? Because this A value you declared with the reg data type. So that A value you are declaring with what? You are declaring with the declaring with the assign statement on the LHS side. Okay, you will get an error. Error. Okay. Similarly, suppose assign B equal to B XOR C. Okay. Here also you will get error. Why? Because whatever the B value is there that you declared on the LHS side, so that will give the that is actually reg data type. Okay. So remember that whatever the variables you are getting on the left hand side, that should be reg data type when you are using continuous assignment statement. Okay. And next, mm, suppose if I want to write the code for the full adder circuit. I think full adder you know. So full adder you designed in the digital. So full adder by using data flow modeling. Data flow modeling. How you are writing? So if you see by using data flow modeling. So here, uh, so the circuit will look like this. So you got three inputs are there, no? So three inputs. It is given to one XOR gate. Okay. So one XOR gate A B C. So A B and C in. Okay. And sum equal to A XOR B XOR C in. Okay. And next carry equal to what? A B and next B C B C in B C in and A C in. Okay. So and carry equal to A C in. Okay. This is AC in. So this one you are giving it to one OR gate. Okay, one OR gate. So what is carry out? So carry out equal to, you got the expression AB plus BC in plus AC in. So this program I need to write by using the data flow modeling. Okay. So how to write the code? So module, Verilog code will start with module and module name. What is my module name? Let us take full adder underscore data flow. So I'm using method 2. So method 2, or you can use method 1 also. Method 1 means what? So method 1 means you need to declare the port list, and separately you need to declare the inputs and outputs. Method 2 is you can declare the inputs and outputs within the bracket itself. Okay, method 2 I'm using input A comma B. Okay, and next I'm using output S comma C out, and I'm using a continuous assignment statement. So when you are using data flow modeling, I need to use continuous assignment statement assign. So S equal to what? S equal to A XOR B XOR C in. Okay. So here last class I told you need to use the this is bitwise XOR operation. Okay. Here this is the XOR operation. No? I need to use bitwise XOR operation, and next assign carry out equal to what? Carry out equal to A and B, or next B and C, B and C in, or A and C in, A and C in. By using bitwise and or operators, I am using this, and next end module. Okay. So like this, for every combinational circuit and sequential circuit, you can use this data flow model. Is it fine? Do you understood how I am writing, how I am using the data flow modeling? Any doubts or queries?
Understood.
Okay, yeah. So just I will show means a basic code. So that uh, whatever the all gates are there, all gates by using data flow modeling. Okay. So RTL codes, suppose all gates, this is the code for all gates. Okay, this is the RTL code I wrote. This is all gates by using GLM. Okay, gate level modeling. So gate level modeling I already told. Okay, so here you see. So what are the gates you have like AND or NAND NOR XOR XNOR NOT buffer are there, no? So first you need to declare the input and output. So module all gates underscore GLM input 1 down to 0 in. So I am using a vector. Okay, this is nothing but two inputs are there now. So that's why 1 down to 0. I am using a vector that is initialized to in and output y and y or y and y nor y xor y xnor y not y buffer. I'm initializing. Okay, and gate level modeling means yesterday I told you gate level primitive followed by output and input. Okay, so y and in 0 in 1, this is AND gate. Or gate level primitive is r y r in 0 in 1. Similarly NAND y NAND in 0 in 1, nor y nor in 0 in 1, x nor xor y, so y xor in 0 in 1, x nor not and buffer. Okay, so this is basic gate level modeling. And data flow modeling also I can write. Okay, for the all gates, simple all gates. Okay, see here. Just module all underscore gates. This is DFM. DFM is nothing but data flow modeling, and I need to declare the inputs and outputs. Inputs I am declaring with vectors, that is 1 down to 0 in, and output is y and output y or y NAND y nor y xor y nor x nor and not. So here I need to use a keyword called, when you are using data flow modeling, you need to use a keyword called assign. Okay, assign y and equal to in 0 and in 1. Okay, assign y are equal to in 0. I'm using bitwise operators. Okay, bitwise and. Okay, and this is bitwise or. Assign y and equal to not of in 0 and of in 1. Assign y nor equal to not of in 0 or of in 1. Assign y xor equal to in 0 xor of y in 1. Okay, like that x nor not buffer I need to write. Is this code is fine? Did you understood? Shall I move forward?
Sir, when we say that this Y and Y or this should not be registered. So here when we say output, is it by default wire?
If you are just you need to remember that you are not declaring any data type means it will take as y data type.
Okay, okay,
If it is a reg means you need to declare with reg data type.
okay,
Okay, the compiler will take here I declared the input and output. I not declared with any data type. By default, it will take as net data type. That too, wire data type it will take.
okay, okay.
Understood? Okay.
Yeah.
So this one, suppose if I want to execute in this Vivado, just I will show the how the circuit you are getting, and so when we discuss the test bench, we can verify and we can simulate these circuits also. Okay. So I need to open this code. This process I told you, no? Shall I tell one more time the process, how to create the project and how to create the files and all those things?
Yeah, if possible, just give some more.
It's clear, no? Last time I told, no? Yes. Okay. So this is a basic code for by using gate level modeling, whatever I explained. So here, see in the simulation also, one more gate level modeling will be created. And here go to like if you want to see the circuit, just to go to open and elaborate the design. Okay. So you are getting this circuit. This is all gates. So AND gate, Y AND gate, that is followed by inverter is Y and directly we are getting the inputs is nothing but a buffer, and through the inverter this is Y naught, and this is OR gate, and next OR gate followed by this inverter is Y NOR, and this is XOR gate, and XOR gate followed by this inverter, there is XNOR. Okay, so depending on my code, this compiler, whatever the compiler is there, this Vivado tool is converting into hardware, that is netlist. This is nothing but gate level netlist, or we can call as schematic. Is it fine? This is gate level modeling. Did you understood how I'm how I'm doing this code? Shall I move forward?
Yes, sir.
Suppose if it is DFM means just this DFM code I told. So select all, just to copy this code. First, what you need to do means this is a GVim. This is a powerful editor. This is available in the Google also. You can install GVim. So copy this module name and go to Vivado, and so here add the design source. Okay, you need to add the design source, create file, and this is allgates underscore dfm, finish. My module name is also same. Yes, so dfm is created. So suppose if you want to see this module hardware, right click, you need to set as top. So here this is made as top module. And next to now, so by default this will come like company, engineer and created. So these all are not required. Just delete this. Whatever this code I explained, just select all, copy this code and paste here. Okay, paste here. This is by using data flow modeling. Okay. So I want to see the circuit, means open elaborated design, save this file. Okay. So we will see how the circuit will work. So same circuit you got by using data flow modeling. Same thing as the gate level modeling you got in data flow modeling. Is it fine?
Yes.
Sir, I have one question.
Yeah, yeah.
If I had one more input, say
Mm-hmm.
input one,
Mm-hmm.
with same type, uh, then I want to do this operations on that input, new inputs.
Mm-hmm.
Will it create a new copy of this hardware, or it will reuse that hardware?
A new input means for every gate you have only two inputs, no? So
Yeah, but
here I am initializing with vectors concept.
yeah, but
So
if I put a one more input one down to zero in one,
in one, okay. Mm-hmm.
and then I do the same operations on in one.
Okay.
and output also y and 1, y or 1, like that.
Hmm.
uh, then the compiler will generate two copies of that hardware,
Means
or it can.
okay, okay, okay. Means whatever you are writing within the module, it will generate hardware. Your question I'm not understanding. Means you need to add three inputs in this, or separately you need to write the code.
Mhm. So I was thinking that if I have one copy of these AND or NAND all the gates,
Okay.
and then I can reuse the hardware for.
Yeah,
Uh,
reuse the hardware means this is normally you need to write. There you need to
mhm.
use parameter concept. So we'll discuss in the
Okay.
future. Parameter concept we need to use when you want to reuse. Suppose suppose ripple carry adder is there, or ripple carry adder fixed size is 4, or suppose
Mhm.
the client will ask some 8 bits or 16 bits. So means during this code we can't change. So
Okay.
when you are using parameter means dynamically we can change the inputs.
Okay. Okay.
Understood? Okay.
Mhm.
So RAM also. Suppose if you are designing 8 cross 8 RAM.
Mhm.
So these you are designing IPs. IPs means intellectual properties. Or you are designing some SoC, system on chip. So you can't
Mhm.
open and you can't write the code. So
Mhm.
client requirement will change, varies. Client requirement will varies. There, depending on client requirement, we can use that parameter concept. That we'll discuss. Don't worry when we
Mhm.
come to
Okay.
that concept. Okay. This fine? Shall I move forward? Coding and data flow modeling and all those things. So like this, what? How many
Okay.
combination
Thank you.
circuits are there? That many combination circuit you can write the data flow modeling. How many combination circuits are there? That many like full adder circuit, full adder, full subtractor, comparator, comparator, encoder, decoder, all those things. You need to use this data flow modeling. Is it fine?
Yes, sir.
Okay. Yeah. So just you can try the different types of codes using data flow modeling. Okay. So this is one piece of code for full adder circuit like that. So if you know, like in digital, we already studied about different combination circuits and sequential circuits. That so circuits you can write the data flow model. Okay. And next topic is signed and unsigned numbers. Okay, signed and unsigned numbers. Okay. Mm, suppose yeah, signed and unsigned numbers. So whatever I gave the task for GLM, gate level modeling, you can try the code for data flow modeling also. Okay. Suppose mux is there, so 2 cross 1 mux is there. So 2 cross 1 mux you can write. So you know that 2 cross 1 mux, 2 cross 1 mux. How many inputs are there? Like A and B, and how many output Y output, and one selection line is there. So you know the Shannon's equation. Y equal to what? A bar, S bar, S bar A plus S and B. Based on this equation only, you need to write. Okay. Assign Y equal to not of S and A, or not of S and B. Okay, like this expressions. Okay, you are using a continuous assignment statement and expressions you need to write. Okay, so that you can try. Okay, 2 cross 1 marks, 4 cross 1 marks, and 1 cross 2 D marks, 1 cross 4 D marks, like that. You can try for all the. So if you are getting any means problem, any doubt in the during the data flow modeling, just please ask me. I will clarify your doubt. Next, we'll go for the signed and unsigned numbers. Suppose This is 0 1 1 0 is there. Okay. This is what this is if it is unsigned number. Okay, how it is defined? Unsigned number, it is defined as normal 6. Okay, and signed numbers are nothing but in digital you already studied, like which one will decide the sign of a number? Can anyone say?
LSB.
MSB bit will decide the given
Sorry.
number is MSB.
MS.
MSB is 0 means given number is positive, and MSB is 1 means given number is negative. Okay, given number is negative. Okay, suppose so this 6 is there. 6, how we are writing? 0 1 1 0. Okay, 0 1 1 0. So 0 1 1 0 means this is the sign bit. Sign bit 0 means what? This you will represent as plus 6. This represented as plus 6. Okay, suppose if you want to represent minus 6, it is represented in which form? Can anyone say? Any idea?
Z 0 0101.
0 1 0 1.
No, from the left, like I was saying.
Triple 1 0.
Triple 1 0. Triple 1 0. Triple 1. Somebody say triple 1. Triple 1 0 0. Mostly negative numbers are represented in 2's complement form. Okay, 2's complement. Why 2's complement form? So you already studied the like negative numbers are represented in sign magnitude, 1's complement, and 2's complement. Okay, 2's complement. So that means here if you see mainly sign magnitude 1's complement, for zeros two representations are there: minus 0 plus 0, two representations are there. So suppose if it is 2's complement, minus 0 and plus 0, only one representation is there, only 0 0 0 0. Okay, suppose suppose if you are representing in sign magnitude and 1's complement, whatever the compiler or whatever the circuit hardware can't decide to store either 0 or minus 0 or plus 0. Okay, if it is 2's complement means only one representation is there. Okay, this you remember. So that means what is 1's complement? So what is 1's complement? 1's complement is uh, this is 1 0 0 1. Adding 1 to this, what you are getting? 0 1 0 1. Okay, so like this it will store. Okay, so in order to convert 2's complement to decimal number, what you need to do means 1 2 4, last MSB you need to keep as minus 8. Okay, you add the weights: minus 8 plus 2, this is equal to minus 6. Do you understood how I am doing? Shall I explain one more time? Hello.
Yes, sir. Understood.
Understood. Okay. So we are, so that means in the data types, I told you wire and reg data types. What are the wire and reg data types? Is these are unsigned data types or signed data types? Unsigned data types are signed data types. During the data types, I told you either it may be unsigned data types or signed data types.
Unsigned.
Unsigned data type. Unsigned data type means, yeah, unsigned data type. Suppose if you are giving a equal to suppose minus 6 I am giving. Okay, so how the, so I want to execute this one in binary and as well as decimal. Okay, so compiler, how it will store? Tell me. This is unsigned data type, no? So compiler internally, how it will store? Any idea?
It will store as it is unsigned and this -6 value.
Yeah,
Uh,
unsigned and -6 value. I want to store the compiler in the compiler. I want to display. Suppose here I'm using this is a equal to -6. I'm using dollar display the value of a. The value of a is percentage b comma percentage d comma a. I want to display. So after executing this, so the compiler how it will take and how it will display. Is there any idea or shall I tell?
0110.
0110. 0110 means this is positive number, no? We are dealing with signed number. This is a signed number. 0110 means it will display in terms of plus 6. This is plus 6. So plus 6 it will not display. So it will display in terms of what means in binary. What is the 2's complement for -6? What is the 2's?
1010.
1010. Okay. So 1010 it will display, but in decimal what happens means in decimal it is unsigned number. It will display 10. Did you understand? It will display the unsigned number. Okay. If it is signed number, we need to declare with how you declare means reg. You need to declare with signed, reg signed, and you need to declare a. Okay, that is 3 bits means 2 down to 0 a. Okay, so when you declare this, so it will be displayed in terms of 2's complement, that is 1010, and decimal means it will display -6. Did you got the point? If it is unsigned means it will display in 2's complement only. In binary form, it will display in 2's complement only. So coming to the unsigned number, it will display this value. Okay, and coming to the signed numbers, you need to declare this data type like this: reg signed 1010. If it is a decimal means it will display like -6. So did you got the point? What I am trying to say?
In the
Yes.
binary, there is no difference.
Binary, there is no difference. It will store in terms of 2's complement only.
Okay.
Okay, but coming to this signed and unsigned, coming to the if you want to display in decimal, it will display like 10, and here this is unsigned.
Mhm.
Unsigned. If it is signed means it will display like a -6.
Yeah.
Is it fine? Okay. So I will show with the program. One second. Signed and unsigned data types. One second. Unsigned and signed operations. Mm, okay. Signed and unsigned. One second. This is unsigned operations. So if you see, uh, hope this is visible. Okay. So I declared that means module unsigned operations. I'm declaring this edge. This is suppose I'm removing this signed. Okay, I'm removing this signed. So I'm initial begin. I'm displaying that means a equal to -3 and b equal to -2. Dollar display the value of e is percentage b percentage d. The value of b is percentage b percentage d. A comma a b comma b. Okay. So normally it will execute in terms of two's complement. Or otherwise I will comment this same example, whatever is the example I told. This I will display. Okay. So the value of b is percentage b a comma a. Okay, a comma a. So whatever I explained, just uh, so run the simulation, run behavioral simulation, save this code. So we need to see the output in TCL console. So here you are getting the value of a is what 0 1 0. So 2 means what? 2 means I took the 1 down to 0 means 3 bits. No, 2 down to 0, 3 bits. Okay, I declared with the 2 bits. Okay, one second. So signed and unsigned operations. 2 down to 0. So 2 down to 0 means how many bits? 3 bits. Okay. So -6. Suppose if I declare with 3 bits. Okay. 3 bits or 2 bits if you declare. Uh, 2 means 3 bits or 3 bits means 4 modules. One second. So I will declare with 4 bits. Okay. So 4 bits I will declare. And if you want to see the simulation, I want to relaunch the simulation. Okay, just relaunch the simulation. So whatever I explained, the value of e is what it is displaying in terms of 2's complement, but in decimal it is displaying in terms of 10. Did you observe the change? Why? Because reg and identity data types are unsigned data types. Is it fine? Did you understood?
Yes, sir.
Suppose if I make this as signed data type. Okay, signed data type. So I will use the signed data type. Okay, signed. Mm, signed, signed. Okay, signed data type. Okay, and I am relaunching. Save this file. Now it's see the value of a means it is displaying in terms of 2's complement, and so what is in decimal? It is displaying -6. Did you understood the difference between signed and unsigned?
Yes.
Okay, is it fine? Shall I move forward?
Yes.
Okay. So this is about the signed and unsigned data types. Okay. Next we'll go with next modeling, that is behavioral modeling. Okay. So what is this behavioral modeling? We'll see. Okay. So introduction to the behavioral modeling. Yeah. Introduction to behavioral modeling. So what is behavioral modeling? In the introduction I told you. So that means the designer will don't care about the internal circuitry. Suppose like full adder is there. What full adder will do? It will add three numbers, and you will get so three inputs are there. It will add one bit, and it will give the outputs and sum and carry. Okay. So so that means in behavioral modeling we are focusing on the designer is focusing on functionality. Okay, functioning, how it is functioning, or we can call as behavior of a system. Behavior of a system. Okay, behavior of a system. And there are some procedural statements are there, so you need to there are some procedural blocks are there, procedural blocks. So this behavioral modeling you need to write between the procedural blocks. Those are nothing but are we can call as sequential blocks also. Okay, procedural blocks are sequential blocks. So that means we need to write between the initial block. Okay, initial block, and we need to write between the always block. Whatever the behavioral modeling is there, we need to write between the initial block and always block. So initial block is non-synthesizable, so we can't convert into hardware. So this will execute only one time, only one simulation time. One simulation time it will execute. It will execute for always. Always means what? It will execute forever. Okay. So this is synthesizable. This is synthesizable. This is non-synthesizable. Only this initial block we are using in the test bench. Okay, and we are using the procedural statements. What are the procedural statements? Procedural statements means like C, we are using like if else. In the behavioral modeling, we are using if else, case, okay, while, for loop. Okay, these are nothing but procedural statements we are using. Okay, so uh, what is the difference between hardware language and HDL? In the starting class, I told you what is the difference between hardware language and hardware descriptive language and software language. I told you, no, software language is serial in nature or sequential, serial in nature. Okay, so it will execute one instruction, one by one instruction, whereas HDL is a concurrent language. HDL is a concurrent. Okay, concurrent language. That means parallel execution will happen uh, in this uh, uh, HDL. Okay, so this is a concurrent language. Okay, um, so suppose first we'll see the initial block. What is this initial block? We'll see initial block. So initial block. Suppose I am writing initial. If you are writing multiple statements, you need to write between the begin and end block. You need to write between the begin and end block. Okay, so if there are multiple statements are there, that you need to remember. Okay, so if you are not using this begin and end, so compiler will throw an error. Okay, multiple lines are there, you need to write between the begin and end. Okay, and suppose like if you consider module initial begin, some statements are there, end. Again, you are writing initial, begin, and some statements, and end and end module. Okay, this is one initial, and this is another initial. So when you are writing this code, which one will execute first?
Both will concurrently.
Yeah, both will execute concurrently. Both will execute parallel. Both will execute parallel. Yeah, that is the correct answer. Both will execute parallelly. And next, suppose if I am using module initial, begin, and next end, and I am using always begin and end. begin and end module. Here I am using this is initial block and this is always block. So here which module will execute first? Can anyone say?
Initial will execute one time and then
Yeah,
always
yeah.
will.
Initial will execute one time. I know, but this is one block, no? Initial block. This is initial block, and this is
Mhm.
always block. Okay. So my question is, which one will be executed first?
I don't know. Maybe I don't know.
Here also both will execute parallel. Both will execute parallel. As this is a concurrent language, both will execute parallel. Okay. Next, suppose module example. I am using assigned continuous assignment statement. Okay. Let us take this is the block one, and I am using initial. So this is the block two, and I am using always also. Always. This is block three. Okay. Here also these all three blocks will execute parallel. All blocks will execute parallel. Then you can ask what is sequential. Okay. So what is sequential means, did you understood? Both blocks will execute parallelly. Okay. Either it may be initial block or always block, or it may be assigned continuous assignment statement, or initial or always blocks when you write within the module. Okay. All will execute parallelly. Okay. All will execute parallelly. So then what is sequential, sir? So what is sequential? So what is sequential means, so there are two assignments are there. One is blocking assignment and non-blocking assignment. Okay, non-blocking assignment, non-blocking. Okay, non-blocking assignment. Okay, so here if you attend any interview, so without this question, the interview will be not there. So they will ask what is blocking assignments and non-blocking assignments. Okay, so blocking assignments are nothing but so the symbol for blocking assignment is equal to, and non-blocking assignment is nothing but less than or equal to. Okay, so blocking assignment means, suppose you are writing initial, begin, begin. Suppose a equal to 0, a equal to I am giving 1. Okay, and after that a equal to 0 I am giving. Okay, so this is nothing but blocking assignment. Okay, so and end module, end and end module. So this will execute sequential. This will execute sequentially. So what is blocking? Blocking is nothing but when this instruction is executed, this instruction will be in blocked state. Okay. After executing this instruction only, this starts executing. Okay, that is nothing but blocking. Okay. So blocking executes sequentially means, or it will execute serial. When you are using blocking or blocking assignments, it will execute serial. Okay. So and remember, when you are using behavioral modeling, LHS should be reg data type. LHS should be reg data type, and RHS can be reg data type, or wide data type, or it can be constant, or it can be integer also. It can be any data type. Okay. So port rule connections you need to follow, that I already told you. And if it is always, always, I'm writing begin. Okay. mm, Here c equal to 0 and d equal to 0 and end. Okay, Here also this will this will execute. So whatever the inside statements are there, that will execute sequential or serial, sequentially or serial. Okay. Uh, so if it is non-blocking means what? So suppose if I am writing always begin, okay, always begin. C is non-blocking with 0 and D is non-blocking with 1. Okay, end module. Okay, so like this, if I am writing means this will execute parallel. Non-blocking assignments will execute parallel. Okay, is it fine with respect to blocking and non-blocking assignments?
Yes.
Okay, yeah. Mm,
Sir, in between two non-blocking, if
mm.
I make a blocking statement,
Between two non-blocking. Uh-huh. So basically, like means where we are using blocking assignments and non-blocking assignment means for designing combinational circuit we are using blocking assignment. For designing sequential circuits we are using non-blocking assignment.
hmm
So that means when you want, so you can't use. Why? Because combinational circuits are nothing but if there any input change in the input, the output will change. No?
hmm,
So where you are using non-blocking means for designing for blocking assignments for designing combinational circuits. Okay, for designing sequential circuits you are using non-blocking assignments. You can't combine both
hmm,
blocking and non-blocking. Is it fine?
okay, yeah,
Okay,
yeah.
yeah. So next, so in the procedural blocks, LHS side should be we need to use reg data type. Okay, so here suppose if you take one example, module module uh, module example module example reg a comma b comma c wire d wire d and begin initial begin I'm initializing d equal to 1. Okay, d equal to 1 and end module. So my question is this code will compile or not?
Yes,
How you are telling?
because D is a wire that is initialized to 1.
Mhm.
There's nothing.
So I told
Ah,
you no. Yeah.
oh, it's blocking.
Yes. Yes. You are using procedural statement, procedural statement, no? Procedural
Mm,
blocks. That is initial and always. By seeing this, this is the which modeling? Behavioral modeling. Okay. This is a behavioral modeling means this code will not compile. Why? Because here D is which data type?
wire.
Y data type. I told you in the behavioral modeling, LHS should be which data type? Compulsory, it should be rich data type. RHS can be either it can be Y data type, rich data type, or it can be constant, or it can be integer also. Okay. So why it is so what is the reason why it is not compiling means so in procedural blocks. So what are the procedural blocks means you have initial and always block. In procedural block uh, on the LHS side we should use only reg data type. Only reg data type. Is it fine? Did you understood?
Yes, sir.
Yes.
Okay, yeah. So coming to the always. So this is about the initial block, and next is always. Always means what? Always means every time, or forever. Every time or forever. Okay. Suppose if I am taking half adder. Okay. Example half adder circuit. Half adder have how many inputs? Two inputs, no? A and B. And how many outputs? Two outputs, sum and carry. Okay. So you know the truth table for half adder. So A B. So this is half adder. A B and sum and carry. So 0 0 0 1 1 0 1 1. Okay. Sum 0 carry 0, sum 1 carry 0, sum 1 carry 0, sum 0 carry 1. Okay. uh, so for this I want to write by using behavioral module. Okay. How to write? So module, what is my module name? You can use ha. I need to declare input and input a comma b, and output should be which data type when I am using behavioral modeling? Can anyone say? It should be
Rich.
reg data type. Yeah, it should be reg data type. And I'm using always at the rate a comma b, always at the rate a comma b. So if it is multiple statements, I need to write within the begin and end. So begin. So that can be hybrid modeling also. So that hybrid means what? I can use so here begin. So I'll use s equal to a XOR of b. S equal to a XOR b, and c equal to a and b. Okay, end model, end model. Okay, so this is nothing but what? Sensitivity list. Okay, always at the rate. That means this is sensitivity list. So what is the sensitivity list? If there any change in the inputs, there is a change in the outputs. Okay. If there so sensitivity list is nothing but if there any change in the input, there is a change in the output. Okay. So like this, you need to write the code for uh, the half adder circuit. Is it fine? Did you understood? Any doubts or queries?
And
Okay. Yeah. Next, suppose uh, suppose module example. I'm using input a comma b, output reg c, initial begin, begin c. Suppose a equal to 0 and initial begin end. I'm giving initial a equal to 1 end module. If this code will compile, whether this code will compile or not, and if it is compiled, what is the value of u? Can anyone guess?
it will be X.
Theoretically speaking, it should be x only. Theoretically speaking, it should be x only. But my question is, when you when you run in the compiler, Vivado or any EDA playground, is this code will compile or not? That is my question. So practically it will not compile. Practically it will not compile. Why? Because here driving values the input will give compilation error. Okay, uh, driving the values. Okay, driving the values to the input will give compilation error. Will give compilation error. Okay, compilation error. So here you can use C or C. C means it will execute. Okay, A means it will not execute. Okay, C means it will execute. Why? Because C is nothing but what? C you are using blocking assignments, and you are using output is initialized storage. So I can drive the value to the output, but I can't drive the value to the input. Okay, so that is the reason. And always block is, I told initial block is are not synthesizable. Always block is synthesizable. Synthesizable means what? We can convert into hardware. We can convert into hardware. Always block is synthesizable. Okay. Uh, Suppose if I am writing always at the rate, let us take a comma b. Okay, a comma b. If I am giving y equal to a, is this will compile? In the sensitivity list, I gave A and B, but here I am giving Y equal to A only. So, is this code will compile?
Yes.
This code will not compile. Okay. So, why? Because here you assign the two values sensitivity list A comma B, but you are using only one sensitivity list. Okay. So, for this you need to write always at the rate A y equal to a means this will compile. Why? Because only one sensitivity list is there. But this sensitivity list you are not using anywhere. Okay, this sensitivity list is nothing but if there any change in the in that inputs, then there is a change in the output. Okay, so that means so like this. Okay, so syntax will be like this: always at the rate sensitivity list sensitivity list. Okay, sensitivity list begin and behavioral statements and end. Okay, like this. Suppose your design is there. Suppose your design have some 100 inputs or 150 inputs, 200 inputs. You can't declare all the inputs in the sensitivity list, no? So in that situation, you need to use a operator called star. Okay, star is nothing but implication operator. Implication operator means if there any change in the inputs, all the it will be applicable for all the inputs. Okay, if there any change in that inputs, there is a change in the outputs. Okay, suppose if you are designing for big project like some SOC or IP, so you have 150 inputs or 200 inputs. These inputs you can't declare in the sensitivity list, no? So in that situation you can use this implication operator, that is star. Okay, so is it fine? Do you understood any doubts or queries?
So this part I did not understand completely.
Hmm.
When you say if there is a in change in the input, there is a change in the output,
Hmm.
uh,
Hmm.
and that I need to give in the sensitivity list. So,
Okay.
uh, uh, well, does it mean that, for example, in my code there is all the inputs are used,
Hmm.
uh, but some of them may not cause the output change? Then I will not use them here. Something like
Okay. Means yeah. Means you need to indicate all the inputs only.
that. Okay,
Suppose
okay.
you need to use all the inputs only. Suppose I will tell you with one example. Suppose if you take 2 cross 1 mark. So 2 cross 1 marks means A, B, and output is Y, and selection line is yes. So I'm using this always at the rate. What are the inputs? Tell me for this 2x1
A
monkey.
and B, A and B and S.
Yes, yeah. So you need to indicate A, B, and S. Okay, and begin. You can use some like if else statement also, or you can use a ternary operator also, or you can use case statement also. Suppose here if s equal to 0, then y y equal to what? So y equal to, you can initialize y equal to a, else y equal to b. So end module. So here what you are using? You are using both A and B, no? Here this is A, this is B. Yeah. You are using A, B and S, no? So these are nothing but sensitivity list. Whether you are using or not, that will be applicable for all the inputs.
Okay.
Is it fine? Okay.
Yeah.
Yeah. So just I want to show about behavioral modeling, and I'm opening the slide. So this is behavioral modeling. You need to use like initial block and always block. Initial block will be executed only one time and non-synthesizable. Always block will be executed means it will be repeated continuously, and so that is block of statements. So this is one example of initial block. It will execute only one time. Okay, zero simulation time. It will execute. Okay, and always means what? Always you need to use like in the in this what we call in the sequential circuits also, I use always at rate passage of clock begin if reset q equal to 0, else q equal to d, like that I can use. Okay, so these are nothing but procedural blocks. So behavioral modeling, this is are nothing but procedural blocks. Initial and always are nothing but procedural blocks. Okay, so you can use
So what
star
is
also.
this clock? This
Means d
clock.
flip flop, for the d flip flops are edge triggered now.
Okay.
So there, if there any change in the clock, they are getting the change in the outputs. Okay, this is nothing but sensitivity list. When you write the code, that I will tell you. Don't worry. Just for the flip flops also, we'll write the code, and combinational circuits also will write the code. When you are writing for the code for the flip flop, you need to use always at rate passage of clock. Okay, that is sensitivity list. So negate means it will change from 1 x z 0 or from x z to 0. Passage means what? 0 x z1 or x z1, like that it will change. Okay. Procedural statements, I told you, no, conditional statement, if else case, loop statements, while, for, repeat, forever, you can use. Okay. So if else statement means if condition is satisfied, code will execute. Else condition false statement will be executed. Okay, while means if condition is satisfied, code will be repeated. Okay, and forever means statement will be executed repeatedly. This is case selector. Case selector, so value equal to 1, code for the value 1, code for the value 2, and there is a default statement also. For every case statement there will be a default statement. Why be so if you are not using case statement, it will infer as a latch. Okay, and for I equal to 0, I less than 8, I equal to I plus 1. This is for loop. Okay, so for this condition is satisfied, this will be executed, and repeat means this will be executed for 3 times. Okay, these are nothing but conditional statements and looping statements, same as C only, whatever the C what you study, that same thing. These are the examples. Suppose for mux I told you, no, so module mux input a comma b comma s, output y, always at rate AR, BR, S, begin. If S equal to, you need to use equality operator. S equal to 1 tick binary 0, Y equal to A, else Y equal to B. Okay. Here I can use case statement also. So I can use implication operator, star. It will be applicable for all the inputs. Cases 0 y equal to a, 1 y equal to b. Default is one tick binary x. Okay. This I will explain why it is written for as latch. And next is integer I equal to 0. I while I is less than 10. Begin display this value. This will execute from 0 to 9. Okay. And this is for loop. Okay, since this condition is satisfied, this will be incremented and this will be executed. This will be repeated for 7 times. Okay, suppose if you want to generate the clock, in the test bench will generate the clock. For that you will use forever. So module clock generator, they will ask the interview question, just to write the Verilog code for clock generator. So you need to write module. My module name is clock generator underscore TV. Reg clock. Okay, reg I need to initialize reg clock. I need to write initial begin clock equal to 0. Forever hash 5 clock equal to not of clock end and end module. Okay. So these are some examples. So this is the example for full added circuit. Output you need to declare with reg data type, always at the rate a and b and c in, sum equal to a xr b xr cn, and cout equal to a b b c in and a c in. Okay.
Sir, you instead of comma, it is used or in the always at the rate a or b or
Anything you can use. The compiler will take.
okay.
Compiler will take. Yeah, compiler will take. Comma you can use or you can use or also. Okay. So I told you, no, continuous assignment statement means you are using in the data flow modeling. Procedural assignment statements means you are using blocking assignments and non-blocking assignments. Okay. Blocking assignment means one instruction is executed, next instruction will be in blocked state. Non-blocking means it will be executed concurrently. Okay. So mainly for the combinational circuits, you will use blocking assignments. For designing sequential circuits, you will use non-blocking assignments. Okay. See here, this is the D flip flop. Always at the rate passage of clock begin Q equal to D. Q is initialized to D. Okay. So these are the blocking assignments. Okay. This is the example for blocking assignments. Order is important. Okay. So it will execute sequential. Non-blocking means it is concurrently. It will execute concurrently. Okay. So this is about the behavioral modeling. Any doubts or queries?